This is practical number 8, analysis of covariance in RBD. So first example in this practical we are having like this: an experiment of sugarcane conducted in 4 randomized block using plots of size 37.12 inches. Each gave the following values of number of plants per plots x and weight of cane in kilogram y. So what we have given here, number of plants per plots x here. So this x is the number of plants here and y is the weight of the cane, that is sugar cane here. The data of number of plants provide a basis for a run control the analysis of covariance for the 3 treatments used, where first nitrogen 350 lb per acre as ammonium sulfate N, second phosphorus 450 lb per acre as superphosphate P, and third potash 150 lb per acre as sulfate of potash of K. So such a way this information we are having, and what we want to do here, test for beta equal to 0. Test for equality of treatments, use y as response and x as covariate here. So here statistical model we are having for analysis of covariance for RBD with one concomitant variable is Yij equal to mu plus alpha I plus theta j plus beta into xij minus x bar dot dot plus epsilon ij, where I varies from 1 to v, means we are having v treatments, and j equal to 1 to r replications, or we can call it as r blocks here, where mu is the general mean effect, alpha I is the fixed effect due to ith treatment, theta j is the fixed effect due to jth block, beta is the coefficient of regression of y on x, and xij is the value of concomitant variable, means the corresponding value, Yij the value of xij, which is the concomitant variable or ancillary variable. Epsilon ij is the random error effect, so that we are having these two conditions for estimating the parameter summation I from 1 to v alpha I equal to 0, j from 1 to r theta j equal to 0. By using this condition we estimate the parameters here, and we assume here epsilon ij is, means error component, is independent identically distributed normal 0 sigma e square. So what we do here, we test here null hypothesis h naught t, that is alpha 1 equal to alpha 2 equal to alpha 3 equal to 0. We are having 3 treatments here, and h1t, that is at least 2 alphas are different here. How this 3 treatments? See, N, P, K, these are the treatments here. So because of that we are having 3 treatments, and it has 4 observations here, means 4 blocks or 4 replications we can call for that. So what we do here, once again the same as in CRD we have done this thing, same table what we have given, that I have copied here and taken some row wise and column wise like in our usual RBD. So while taking sum, we take sum of these 4 observations, that is this value, sum of this 4, that is this value. Such a way we have obtained these sums. These are the treatment sums here. So because of that we call this as TI here. Okay, TI here. This is for TIX, T1x we call, this is T1y, and such a way T2x, T2y here, and T3 and T3x and T3y. And here what we are having here, sums for block sums we are having actually. So totals we are having, so because of that I have written here T. While taking this sum, we are summing here xj I am calling here. So x values means this 41 plus this 42. Such a way we obtain this value 124. Similarly 122 plus 81 plus 80, this gives us 283. Such a way all these sums done here, and this is sum of these values here, and this is the sum of this value, that is total of x values and total of y values here we are having. Or you can get this value by summing this also, 160 plus 179 plus 174, that is this txj you will get. Or this 1101 can be obtained by using this 501 plus 315 plus 285. By using that you will get this sum. So this is total, means grand total of x and grand total of y values here. Okay, this we require ti square, so because of that I have written here. Then next what we do, in the next we find out the correction factor here. Correction factor CF we find out j square by n, usual formula we are having, and gx we have obtained double summation xij, that is 513, and double summation yij, that is 1101. Just now we have obtained here this one 513 and 1101. This sums we call it as gx and gy, corresponding sum grand total for x and grand total for y we are having. Total number of observations are 12 here, 4 blocks and 3 treatment. So 4 3s are 12 observations we are having here. CFX can be obtained gx square upon n. So gx square means this square divided by n is 12 here. So we get this value. CFY is g square y upon n. So g square y means this square divided by 12 once again, will get this value. CFXY we obtain gx into gy divided by n. So gx into gy divided by n is 12 here, we get this value. So we have obtained all the correction factors here. We'll go to the next part. TXX, treatment sum of squares and sum of products we obtain. So how to obtain this? Txx is summation I from 1 to v tix square upon r minus cfx. So tix square upon r is constant, you can take this outside the summation also, tix square here. Tix square means this values. This value. Just see, this totals we have obtained, this 3 totals actually. Because I is varying from 1 to 3 here, 3 treatments. So we are having this 160 square, 179 square, plus we are adding that, means this value 25600 plus this 174 square is this value. So add these 3 values, this 1, 2 and 3, will get this value here, this summation here, divided by 4. So divided 4, because we are summing when we are obtaining this tix square, tix, this sum we are obtaining, then we are summing those 4 observations. So divisor is 4 here, minus cfx. Cfx just now we have obtained, that is 21930.75. So we have written that here and taken subtraction, will get this value. Similarly tyy we obtain tiy square upon r minus cfy here. So how to get this tiy square here? Once again this neighboring values here, this one here. TIY means this treatment 1, its sum, we are having this sum, so its square. Treatment 2 is P here, related to Y, this is sum, its square we are having this value. Treatment 3 is this K treatment, 285, its sum related to Y and its square is this. So we add these 3 values, divide it by 4, will get this. This addition is this one, divided by 4 minus CFY, and CFY value is this value. So that value substituted and get the subtraction, and we'll have this one here. Then next we are obtaining TXY, that is equal to summation I from 1 to v TIX into TIY upon R. Here it's very simple to obtain. Just now we have done the squares. So what we have to do here, we are having 3 treatments. So TIX is this value and TIY is this value. So multiply this with this. 160 into 501 plus 179 into 315 plus 174 into 285 and divide that sum by 3 here. Sorry, not 3 here, it is 4. Sorry. This is divided by 4 and minus CFXY, that CFXY related to CFXY, we are having this value 47061.75. That subtracted will get minus 534 here. See here, this is sum of products, so it may be negative here. But txx and tyy, these are the sum of squares, so they are not negative here. These are sum of squares, txx and tyy, so they should be positive here, non-negative terms we should get here. But txy is sum of products, it may come negative here, so we are getting this negative value. Okay, then we'll go for block sum of squares and sum of products. So same way we obtain block sum of squares here, bxx, that is txj square upon v minus cfx. So how to obtain this txj square? So that is this txj here. Means how we have obtained this 41 plus 41 plus 42. That is this value we are having txj. Its square will do here, plus this square plus this square plus this square. Square all this and take its sum and divide it by 3, because we have added only 3 values while obtaining this sum 124. So because of that we divide there by 3 here while obtaining this block sum of squares. So divided by 3 minus cfx, that cfx we are having in the previous case also. So take its subtraction, we will get this value here. Similarly we obtain byy, that is tyj square upon v. So once again the same thing we will do here. Tyj square means this value. How we get this value? This value plus this value plus this value, that is 283 we are having, and its square plus this square plus this square plus this square. Add the squares of these 4 values and divide it by 3 and subtract the cfy there, cfy. So this sum we are having divided by 3 and minus this cfy, that gives us this value. Then txj into tyj here divided by v minus cfxy. So it's very simple to obtain here. What we have to do here, multiply this value 124 with 283 plus 128 plus 128 into 282 plus 138 into 282 plus 123 into 254. Such a way you will get that numerator value there, and then what we have to do here, divide it by 3. This value is the numerator value. By multiplying that and adding this value, we are dividing it by 3 minus cfxy is this value. We'll get bxy is this here. Block sum of products here. Xy means it is sum of products, and xx and yy, this is sum of squares here. So we'll go for total sum of squares and sum of products here. Every time we are getting total sum of squares same in every design, that is double summation xij square minus cfx here. Similarly ssyy we are having double summation yij square minus cfy, and ssxy is xij yij minus cfxy. So how to get this? You are having this idea. I'll tell you here how we are getting that double summation xij square. Xij are this values here, this 4 and this 4 values, this 12 values we are having relative to xij. So what we do here, 41 square plus 40 square plus 38 square plus 41 square, and likewise we add these squares of this and plus last value is 40 square each and every observation of x value, and divide it. No, we are not dividing, we are adding only those squares here and minus cfx over there. So that gives us total sum of square. We are not dividing here any term, only we are squaring and summing those values here, related value, and minus cfx. This gives us, this is the total sum of square related to x value. Similarly we obtain for y values, that what we do here, this square plus this square plus all these squares we add plus 58 square. This 12 values we are having related to y, square each and every value and add those square that we give. That gives us here double summation yij square minus cfy that we have obtained. Subtract it, will get sum of square due to y here, or related to y here. Sum of product related to xy we are having, that is xij into yij. It's very simple to obtain here. Xij into yij means corresponding x value related y value, multiply this with this with this, and so on. Last value we are having this 40 into 58, multiply this with this, and After multiplying, add those values, we'll get this double summation xij yij here and minus cfxy. Cfxy, we are having that value. Subtract it, we'll get this as the total sum of products here. This is also negative here because it is sum of product may come negative here. So don't take tension of that. It may be. Then how to get error sum of squares and sum of products? Here error sum of square we obtain by subtraction. Total sum of square minus treatment sum of square minus block sum of square. All the sums we have obtained, substitute value and get this answer here. Similarly for yy and for xy also, by doing this we'll get these values here. It's very simple. All these sums we have obtained in the previous slides, so use those sums and get this value as error sum of squares exx, eyy, exy. Then after this what we do here, we find out treatment plus error and that we call as e dash xx, means treatment sum of square plus error sum of square, not actually exx and txx, sum of squares actually there. And this will get e dash xx here, that we are having 213.333. Similarly for y we do here eyy plus tyy. This is what here treatment actually. Okay, treatment plus error we are doing here. This is exx and txx, not total here actually. Here we are having treatment plus error, we are adding that and we are calling that as e dash xx, e dash yy, e dash xy, exy plus txy here. For total sum of square, what we have denoted here, SSXX, so don't get confused in TXX and SSXX. So SSXX is sum of square for XX here, sum of square for YY, and sum of square actually it is sum of product actually XY here. Okay, so we are having this error sum of square also, and this e dash xx, e dash yy, e dash xy. How we have obtained this exx and txx, error plus treatment, those we have added and we get this value. So whatever information we are having, that we substitute, that we put in the table. Afterwards just we find out some terms we require. SSE can be obtained here, eyy minus exy square upon exx. So substitute all these values, three values here, we'll get this as SSE. And SSE star, adjusted sum of squares we are obtaining here, that is e dash yy minus e dash xy square upon e dash xx. How we have obtained this value? Just now we have obtained this values, these values we are using, and we are obtaining this here, SSE star. So substituting values we get this as the answer here. And SST, sum of square due to treatment, it is also adjusted sum. SSE star minus SSE means this minus this. If we subtract from this with this, we'll get this, that we call it as SST, sum of square due to treatments here. Then after getting this, what we are having here, MST we are having, that is SST upon V minus 1. How we have obtained SST? This is SSE star minus SSE, means this value divided by V minus 1. V is equal to 2, 3 here. 3 minus 1, it gives us 2 here. So SST means this value divided by 2, will get this answer here. And MSE, we are having SSE divided by R minus 1, V minus 1 minus 1 here. SSE means this value 283.4863. This value we use here and divided by R minus 1. R is number of replications, that is 4. 4 minus 1, it is 3. V is equal to number of treatments here. So number of treatments is 3. 3 minus 1, it is 2. So 3 into 2, it gives us 6. 6 minus 1, it is 5. So this value divided by, sorry, not this value, SSE, this 283.48, this divided by 5, this gives us 5 here. So after dividing this by 5, we'll get this answer here. Okay, so this information we require to put in the table. So because of that, we are obtaining all this information. Beta hat can be obtained exy upon exx. Exy and exx, just now we have obtained here in the previous slide. Exy is this and exx is this value. So those values we have substituted and we got this as beta hat as minus 0.9909 here, and beta dash hat is e dash xy upon exx. This values in the previous slide we are having. E dash xy is this value minus 697.33 and exx, that is 213 here. So this value we are having this one here. By dividing this with this, we are getting 3 minus 3.26. So beta hat and beta dash hat we have obtained. Then this is the general, sorry, this should be RBD here. Okay, this table we are having as the ANOCOVA table for RBD. This I forgot to make correction here. This should be RBD here. So what we are having here, source of variation, that is block, treatment, error, treatment plus error and difference. This we are having here. Its degrees of freedom, block is R blocks or R replications we are calling, so R minus 1. V treatment, so its degrees of freedom is V minus 1 here. Error is R minus 1, V minus 1. Our usual RBD, if you are knowing, same degrees of freedom we are getting, R minus 1 into V minus 1. And treatment plus error. Treatment plus error means this V minus 1 plus this we are adding R minus 1, V minus 1. If we add this both, we are getting this R into V minus 1. If you try to add, you will get V minus 1 as the common factor there from this and this. So what we remain in the bracket, R minus 1 plus 1, and that minus 1 plus 1 cancels and we'll get that bracketed term gives us R here. So because of that we'll get R into V minus 1 here. Okay, so such a way we get this degrees of freedom here. Then next we are having this sum of squares and sum of products here, SSXX, SSYY, SSXY here. So block sum of square, block BXX, BYY, BXY, TXX, TYY, TXY, EXX, EYY, EXY here. And this treatment plus error just now we have obtained, we call it as E dash XX, E dash YY, E dash XY. And estimate of beta, that we are having beta hat is EXY upon EXX, and beta dash hat is equal to E dash XY upon E dash XX here. Here adjusted sum of square we call it as SSE, SSE star, and adjusted degrees of freedom we are having this is the error degrees of freedom, because we have estimated that one more parameter beta, so because of that 1 degree of freedom get reduced here. So because of that R minus 1, V minus 1, minus 1. Here we are having actual degrees of freedom is this, but because of that one parameter, more parameter, we have estimated beta here. So because of that this 1 degree of freedom get reduced here, and we call it at adjusted degrees of freedom. Similarly here also, this is our actual degrees of freedom, we subtract it from 1, we'll get that is degrees of freedom adjusted to this one here. And if we add this with this, sorry, not addition here, actually we are subtracting here and we are getting this one. See this how we are getting here, SST we are getting SSE star minus SSE, means this minus this. Same way we are doing this minus this here. See, treatment plus error is this one, and we subtract from that error, so we should get here treatment degrees of freedom. So this gives us treatment degrees of freedom, that is V minus 1 here. So we are getting that as the V minus 1. So this minus this we do, will get this one here. And how we get this adjusted treatment sum of square SST, that is SSE star minus SSE. All this information we have obtained in the previous slide. We substitute those values in the table and we get the table like this here. All those values what we have obtained previously, that I have substituted over here. I'll tell you degrees of freedom here, 4 blocks or 4 replicates, so because of that here 3 treatments, so because of that here 1, 3 into 2 6, so we get 6 here, and this gives us 8 here, treatment plus error, that is 6 plus 2 8 here. That way also you can obtain here. And here 1 degree of freedom get reduced because of that estimate of beta, so we'll get 5 here. Here also 1 degree of freedom get reduced, so we get 7 here, and 7 minus 5 gives us 2 here. So this every information what we have obtained, so that we have substituted in the proper places here. This is BXX, BYY, BXY, TXX, TYY, TXY, EXX, EYY, EXY. This is E dash XX, E dash YY, E dash XY here, and this we have obtained in the previous slide, that we have substituted only here this value here, beta hat and beta dash hat, that we have substituted over there in the table here. SSE we have obtained, SSE star also we have obtained. SSE star minus SSE, taking subtraction from this to this, we are getting this value, and corresponding degrees of freedom are this one here. So then after that we test firstly H naught star here, beta equal to 0, and for that we are having F is equal to E square xy upon EXX divided by MSE, and which follows F with 1 degree of freedom, R minus 1, V minus 1, minus 1. Thus is the adjusted error degrees of freedom here. Okay, so we are having this here, and what after substituting value here 1 here, and it should be 5 actually here, 1 and 5 here, R minus 1, V minus 1, minus 1, so it should be 5 here. Okay, so 1 and 5 that we have to see here. So because of that this value also changes here. Just correct this value, what this value is. Okay, correct this value, what value we are having, this 1 and not 6 here, because R minus 1, V minus 1, it gives us 6 minus 1, that is 5 we should have here. So 1 and 5 it should be. Okay, that value we have to obtain and then use that value for comparison. So after doing this ratio here we are getting 2.85 here. It will not changing much more, it is near about to this value. So we'll get the same decision what we are having here, F calculated less than F15 here, it should be 5 everywhere here, this everywhere it should be 5, not 6 here. 0.05 except H naught star at 5% level of significance, that is beta equal to 0. So this gets accepted here, beta equal to 0. Then we test the hypothesis, actual hypothesis H naught T we want to test here, that is alpha 1 equal to alpha 2 equal to alpha 3 equal to 0, and its test statistics we are having as MST upon MSE, ST square upon SE square. MST is the sum of square here, this SST divided by its degrees of freedom here. SST we have obtained adjusted here, SSE star minus SSE. So that we are having an SST here upon its degrees of freedom into MSE is SSE and divided by its degrees of freedom, that is R minus 1, V minus 1, minus 1 here. Degrees of freedom, this once again we are having adjusted degrees of freedom here also. So this values, this value, final values we are having, that I have substituted over here, and this gives us 41.69 here. Just a minute, I will show you this value, MST and MSE we are having this value. Yes, this is MST, that is 2364.21, and here 56.69 MSE. So these two values we have used here and got this 41.69 here. And the statistics, it follows F with V minus 1 treatment and error degrees of freedom, that is adjusted error degrees of freedom here. V minus 1, R minus 1, V minus 1, minus 1 here. So I have taken here correctly. In the previous case only I got that, forgot to take 5 here. So F25 here. So F25, that is 5.78 we are having, and we are having this decision rule. If F is means F calculated is greater than F this table value V minus 1, R minus 1, V minus 1, minus 1 alpha, then reject H naught at alpha percent level of significance, otherwise we accept H naught. See here, F calculated is 41.69 here. So it is too much larger than this one. So very significantly we are having this significant difference we are having here. F is greater than F25, therefore we reject H naught at 5% level of significance, that is treatment means differ significantly here. Thank you.